Good morning. In this first lesson of Unit 10 on equations that are logarithmic and exponential and solving them, we're looking at learning about what we know as the properties of logarithms. And the properties of logarithms can be used for all base values. That includes our common logarithm, which is a base 10, which, remember, often doesn't show the subscript, and the natural logarithm, which is our base e, which has its own special notation ln for a logarithm of base e. The properties of logarithms are like the order of operations. When you're using them in problem solving, they have to be used in a particular order. So the first property that we use is like our exponent property. It is called the power property of logarithms. And it can be used to either take an exponent here, such as the n, and move it to the front of the logarithm expression as a multiplying factor. Or it can be used to take a multiplying factor, such as n times a logarithm, and move it to the exponential position on the argument of m. Once we're done using that property, then we would use either the product and the quotient, and we would do those from left to right, just like we do multiplication and division. So this is what it corresponds to in our basic math, is our multiplication division from left to right. So we use our properties, our product and quotient properties of logarithms at this point. And they can be used again in either order. So if we have, and this is primarily what we'll be doing today, if we have a sum of two logarithms of the same base, then we can rewrite that as a single logarithm of that same base if we multiply the arguments together. And if we have a difference of two logarithms of the same base, then we can rewrite that as a single logarithm of that base by dividing the arguments. And it must be the first argument divided by the second argument in this property. Once we have an expression of a single logarithm, such as the log base b of m to the power of n, or log base b of m times n, or m divided by n, then we can use definition-based properties, such as log base b of b equals 1, log base b of 1 equals 0, or log base b of b to the m power equals m, to help us with simplifying logarithmic expressions. There also is a change of base property of logarithms that allows us to take a logarithm of any other base and rewrite it as a new based logarithm, given a quotient of those two logarithms of our new base, where the argument of the original logarithm becomes the argument of the numerator logarithm, and the base of the original logarithm becomes the argument of the denominator logarithm. All right, so let's look at using these properties to simplify and evaluate some expressions that involve our logarithms. So here we'll look at this one. We want to use the properties of logarithms to simplify this expression here as much as possible. We want to make sure we show our steps. So again, we have to use, like order of operations, the properties of logarithm in a particular order. So the first property we have to look to see if it is necessary to use is our power property of logarithms. And here in this particular expression, we have to recognize the need to use that by the multiplying factors of 1/2 and 2. So in our first step, both of those multiplying factors will be moved to the exponent positions and the arguments of 16 and 5. So we're using the power property here. And this gives us now log of 16 to the power of 1/2 plus log of 5 to the power of 2. And then we would look at simplifying each of these. And so recognizing that log 16 to the 1/2 power, this would become the log of the square root of 16 plus the log of 5 to the power of 2, which again would be 5 squared. And our square root of 16 then gives us a 4, so this becomes the log of 4 plus the log of 25. Once we've completed that process, then we look at moving on to the next set of properties, which are our product and quotient. And this plus sign between these two arguments is now what tells us that we need to use the product property of logarithms. And the product property then allows us to, and says that we can, take the sum of these two logarithms of base 10 and write that as a new single logarithm, still of base 10, by multiplying the arguments of 4 and 25 together. And so that would give us the log of 100. At this point, we are now looking at using any identity-based properties to help us evaluate this. This is actually something that we learned in the previous unit. This is logarithmic form. And in this logarithmic form, we can realize that, all right, well then what we're looking at here is a base of 10, and 100 is power of 10. And so this would be the log base 10 of 10 squared. And you could also do this the way that we looked at in the previous unit, but this is another way to look at it. And so there's a property of logarithms, if you look back here, that says if we can create this structure here where we have a base b and a b here with an exponent of m, that'll just be equal to that power of m. And so this is using that log base b of b to the m power equals m. And so that means that this 2 is the value of this expression. And we're done. All right, let's look at the next one. All right, so in this particular one, again, we would first look to see if the power property of logarithms needs to be used. And we look in front for multiplying factors. Here, we have a multiplying factor of 1, and anything to the first power is itself, so it's unnecessary to use the power property on this particular expression. The same thing here. You could look at this as like a plus negative 1 times the logarithm, but in this particular situation, it's usually just easier to look at this minus positive 1 times the logarithm, and so we do not need to use the power property here. So that means that we move on to the next set of properties, which are the product and quotient. And this minus sign here, between these two logarithms of base 3, tells us that the first thing that we can do here to simplify would be to use our quotient property. And the quotient property of logarithms says that we can take this difference of these two logarithms of base 3 and rewrite it as a single logarithm of base 3, as long as we divide the two arguments. And it must be the first argument divided by the second argument, like so. You can look at now this argument of 27 over 81 and recognize that 27 and 81 do have a common factor and can be reduced. Their largest common factor is 27, and this actually simplifies to log base 3 of 1/3. So now what we should recognize, now we have a single logarithm, so we can move on to those identity properties of logarithms, which is similar to looking at this as logarithmic form and being equal to an exponent value. And so what we're looking at now here is that 1/3 is a power of 3, and we have a base of 3. And so this would be log base 3, and remember we've talked about this as first power, and so we pull it up to the top, and that gives us 3 to the power of negative 1. So again, we're looking at using that property of log base b of b to the power of m would be equal to the exponent value of m. And so this tells us our logarithm has a value of negative 1. And we're done. All right, so if you'd like to practice this one, I'll pause the video here. Here is the answer to the practice problem. And here's another practice problem. If you'd like to pause here and do this one. Here is the answer to this practice problem. All right, let's take a look at this next example here. So here we recognize we were dealing with our natural logarithms, log base e. And so we're still doing the same thing. Remember, our properties of logarithms work with logarithms of all bases, including our natural logarithm, which is our base e logarithm. So we're again looking for multiplying factors in front of any logarithm expressions, and we find this 3 here times this natural logarithm of 2. And so that tells us the first thing we're going to want to do is use the power property. And so we rewrite this expression as the natural logarithm of 10 plus the natural logarithm of 2 to the power of 3. And then simplifying 2 cubed, this gives us the natural logarithm of 10 plus the natural logarithm of 8. Then again, we move on to the next set of properties, which together are the product and quotient properties. And recognizing that this plus sign right here tells us we should now use the product property of our logarithms. And so we rewrite this now as a single logarithm of base e, so a single natural logarithm with a new argument that's the product of the original arguments of 10 and 8, which now then gives us the natural logarithm of 80. Now at this point, we need to realize that we're supposed to remember simplify as much as possible. In the previous problems, we had arguments that were powers of our base. Well, our base here is e, and 80 is not a power of e, and so this is actually the most simplified that we can make this particular logarithmic expression. And that would be the end of that one. All right, and this example now. So now we're looking at an expression a little more complex. It adds a third logarithmic expression. We go through beginning again with our power property of logarithms. And so we're looking here, we see this 4, this 1/3, which then tells us that we will begin again with our power property of logarithms, giving us log base 4 of 2 to the 4th power, plus log base 4 of 27 to the 1/3 power, and then our minus log base 4 of 6. And simplifying each of those power situations, we now have log base 4 of 16 plus log base 4. Remember, this would be the cube root of 27 here, so that becomes a 3 minus log base 4 of 6. Then we're looking at using, again, our product and quotient properties for logarithms. We have this plus, and we have this minus. And remember, we have to do things from left to right, just like we do with multiplication division in basic math. So that means we have to do this first, the plus, which is our product property. Rewriting this now as log base 4 of the new logarithm with our argument of 16 times 3, which gives us log base 4 of 48. And we still have the minus log base 4 of 6 over here. So now we'd move on to the minus situation. And that now tells us that we will do use the quotient property of our logarithms. And rewrite this as log base 4 with a new argument where we divide the original arguments, 48 and 6. And this will give us log base 4 of 8. And in this particular situation, what we're looking at is using our understanding that 4 and 8 are both powers of 2. So if we use our exponential form, where this is equal to, remember, some exponents, call it n here, we'd have 4 to the power of n equals 8. And then each of those being a power of 2. This would be 2 squared to the power of n, something we did in our previous unit, and 2 cubed. And then we know our power of a power property says this would be 2 to the 2n power equals 2 cubed. And then our property of equality for exponents tells us that now that they're both bases of 2, that those two exponents of 2n and 3 must actually be equal to each other, giving us an equation we can now solve for n, giving us an n value of 3/2. And so remember that the n is not part of our problem, but we're looking at our original logarithmic expression being equal to our n value. So our, let's see, what was it? Just going to put it up here, I think, for clarity. So this is equal to our 3/2, like so. All right. If you'd like to practice this one, go go ahead and pause here.